Hey, so in this lecture, we are going to look into how data replication is being done in a key value store. So now we have discussed about data partition. So we know how data partitioning works, how the data is being distributed evenly with minimal data movement whenever the server is up and down. So consider a scenario. So just replicating the data partition thing. So what I have is a hash ring. I have the servers, say I have 4 servers, S2, S3, and the keys are distributed evenly through our hashing, consistent hashing technique. So as you know, this key 1 and key 2 are mapped to S1, key 3 and key 4 are mapped to S2. This is mapped to S3 and this is mapped to S0. So let's say in a worst scenario, in a certain situation, this S1 server is down. And the client wants to fetch some data for corresponding key 2. So as you have learned earlier, like if the server is down, we need to perform a data movement. However, the amount of data movement is being reduced, but since till then there is some latency also involved for this data movement, although it's much lower, but it is still there. Can you think of a probable solution? How about I reduce this latency further? See, latency can't be eliminated at all, but this can be reduced much more and we can get a better solution. Can you think of something about it? So as you can see, what if this key 1 and key 2, these are also present here. These are also present here. So whenever my client wants to fetch key 2's data, it sees the server 1 is down, but the server 2 is up, the server 3 is up, and it has this data. So server 2, what it does, it gives back the data with some logic implementation, and that client receives the data. So this thing, what we have done is, we have replicated these keys to server 2 and server 3 when the server 1 is up, and whenever we were writing these keys to server 1. So to achieve high availability and with a reliable design, we asynchronously replicate our data to say n servers. Why do I say asynchronously? To get a better performance. And we'll further see what this asynchronous also helps us in near future. So whenever this data, suppose now let's say server 1 is up as usual and it's running. So whenever first time this data is being written into S1, what it does is it replicates this data to say let's say S2 and S3. So now this data replication happens. Consistent hashing, what we do is we also move in a clockwise fashion, as you know. So this replication happens in a clockwise fashion if you consider the consistent hashing case. So this S1 will get the data of key1 and key2 along with, if we go clockwise, S2 and S3. Now the data is being replicated. So you all might also have remembered we had introduced a earlier concept called virtual server nodes. So these are actually virtual server nodes which indirectly maps to the physical server nodes. So let's say suppose I have S1 0 here, S2 0 here, S3 1 here. So and if we move clockwise, then so let's say this one is S1 1, another virtual server for server 1. And if we move clockwise, then key 1 is again mapped into server 1 but through its virtual servers. So this, let's say S1 0, S2 and S1 1. So to reduce this load on S1, what we do is we avoid the virtual servers and we choose n unique physical servers. We choose n unique physical servers. This is one thing we keep in mind. We choose n unique physical servers. Another thing is, what if, let's say, server 1, server 2 are in the same data center, whereas server 3 is another data center, server 4 is another data center. And by moving clockwise direction, we have put our most of the keys here. Key 1 to key 2 is here in both server 1 and server 2. And there is a power outage or a data center is down. Then, even though we have replicated our data, this data is unavailable to us. Since the data center, there is a power outage at data center and the server 1 and server 2 are unavailable. So to avoid this, what we also ensure that the replicas are in different data centers. Replicas are in different data centers. So in this way, what we can achieve is we can replicate our data in different centers, and even if a server is down or even if a particular data center is down, other servers are holding our data and we can easily fetch those data. We'll see how we can get those data, what is the underlying architecture behind it, how the data is being fetched from other data centers whenever a particular server is down. We'll just immediately look into it into our next presentation or the next building block, you can say. So I hope you remember those 8 building blocks or frameworks which I have discussed earlier. So this was our second building block, that is data replication. So just to give a recap of what happens in data replication is like, we have these keys. Earlier the keys were evenly distributed in data partition, and we, in order to minimize those movement, we put it in a consistent hashing in a hash string, and the data are being mapped into a particular server. But suppose a server is down, so what we do is we replicate those data in a hash string manner using the consistent hashing technology and moving in a clockwise direction to S2 and S3. To note, these servers should be unique physical servers. Suppose we choose a hyperparameter like n servers, n equals to 3, let's say. So this should be unique physical parameters, and moreover, these physical servers, although if we are moving in a clockwise direction, let's say S1 and S2 are in the same data center, we mostly try to avoid the replication in the same data centers. Maybe a data center there is a power outage or a network failure or some natural disaster has happened and that data center is unavailable. Thereby, server 1 and server 2 are unavailable. So thus, we try to replicate this data in different data centers. So now, after the replication, how can we maintain the consistency of the data? Suppose a new data has been written in S1, and if there is a network failure between S1 and S2, how they are replicated, how they are communicated, how this consistency is maintained. And even though there is a network failure or between two servers, or how we maintain the availability of the data, we will now discuss in the next section, which is also our third building block, if you remember, that is the consistency.